Next, we will be simplifying expressions with rational exponents. So this time we have expressions, meaning we'll have x's and y's in it. So I want you to use the following exponent properties that we've used in the past to simplify the following expressions with rational exponents. Now, don't forget that all of your answers should have only positive exponents. So the only difference about these problems that we're doing here and the problems that we did in a previous section is that the exponents, which used to be whole numbers, are now fractions. For example, if I gave you the problem x cubed times x to the fifth, you would just add your exponents, keep your base the same, and get x to the eighth and move on with the next problem, right? Well, this is very similar to what we have here. That is going to be using the product property. I need to add my exponents, and if it was as simple as the problem in red above it, then you just add 3 plus 5 and get 8 and move on with your life. The reason that this is hard is because you have to add fractions, and adding fractions takes a long time. Notice that the base stays the same, and then I take 1/5 plus 3/4. So that means I have to come over here on the side of my paper and work out what that means. I need a common denominator. Remember, when you're adding fractions, that's when you need a common denominator. Looks like the LCD is 20. So I am going to multiply the numerator and the denominator of the first fraction by 4/4. So that gets me 4/20. On the second fraction, I need to multiply by 5/5, which gets me 15/20. So 4/20 plus 15/20 gets me 19/20. So my final answer is x to the 19/20. There's nothing else I can do to simplify that or make that any better, so that's all I can do. The next problem has a exponent on the outside with two bases on the inside. Remember, 25 is a base and so is x, which means to get rid of the parentheses, I need to take this 1/2 and it needs to be applied to both. We've done this in the past with much nicer numbers than a half. For example, 2x squared cubed. The 3 needs to be applied to both the 2 and the x, which gets me 2 cubed x to the 6. Remember, we multiply those because that's the power property. And then I would just get 8x to the 6. Now this one wasn't too hard of a problem, I just did up here in red. The reason that this blue problem down here is harder is because you have fractions in the exponent, which just makes everything just that much more annoying. So the 1/2 has to be applied to the 25. So we have 25 to the 1/2. X to the 5th needs to be applied to the 1/2. Remember, what we do there is we multiply. So I have to take 5 times 1/2. If you multiply your tops, you get 5. Multiply your bottoms, you get 2. Notice on multiplying, I don't need a common denominator. Now on the second parentheses, there is no exponent on the outside, so he just can come right out of the parentheses without any work. The 25 to the 1/2, because it is a number base, I can change this into the square root of 25 to the 1, which will turn out to be 5. Also, the other number we have is 3, so I'm just going to bring that closer. And then we have x to the 5/2 times x to the 1/4. Just like the problem that we did over here in green, we are going to have to add our exponents. So that's going to get me x to the 5/2 plus 1/4. And then I need to come over here on the side of my paper and add 5/2 plus 1/4. I need a common denominator. The common denominator looks like 4. So I will multiply the numerator and the denominator by 2 to get 10/4, and multiply the numerator and denominator of the second fraction by 1 to get 1/4, for a total of 11/4. So that I add my exponents to get 11/4, so that gets me x to the 11/4. In the front, I had a 5 times a 3. Well, that's just 15. So my final answer is 15x to the 11/4. Notice on this last one we did the power property, we used the product property again, and we used the distributive property. So we are using these properties from that we've used in the past, just with the fractions now. On this next one, notice in the numerator we have a negative exponent. Okay, the first thing I would probably want to do here is make any exponents that are negative positive by moving them to make them happy. Be careful though, because 5 is a negative, but it's a negative on the base. The negative on the base doesn't get to move. He just stays put. He's just a negative number. The negative on the exponent of 2, that's not happy where he's living. He's going to move downstairs. Y to the 1 stays upstairs. In the denominator, 10 stays downstairs. X to the positive 1/4 stays downstairs. And y to the positive 2/3 again stays downstairs. Okay, so let's work out the numbers first. Negative 5/10 is just a fraction. We don't get to use the exponent rules that are listed here to the left because there is no exponents on 5 and 10. We just have negative 5/10, which reduces to negative 1/2. Now let's look at the x's. We have two bases of x's in the bottom, so because they're together on the same level, we're going to use the product property and add their exponents. But again, I don't know what that is, so I'm going to come down here in the bottom and add 2 over 1 plus 1 over 4 and get a common denominator of 4. So the first fraction, it looks like I need to multiply by 4. So that gets me 8/4. On the second fraction, I multiply by 1, or just bring it on down, which gets me 1/4. And 8/4 plus 1/4 is 9/4. So we have x to the 9/4 in the denominator. For the y bases, we have one in the numerator and one in the denominator. We are going to use the quotient property. The quotient property says take the top one minus the bottom one. So the exponent of the y in the numerator is an exponent of 1. So I have 1 over 1 subtracting 2/3. So I have to get a common denominator there of 3, which means I'm going to multiply the first fraction by 3 to get 3/3. The second fraction I can multiply by 1 to get 2/3. And 3/3 minus 2/3 is equal to 1/3. So the x to the 1/3 needs to go where? In the numerator or the denominator? Well, because there is more y's in the numerator, there's one whole y in the numerator and only 2/3 of a y in the denominator. 1 is bigger than 2/3. That means my leftovers will go in the numerator, y to the 1/3. There is nothing else I can do here for this problem, so I am done. On this next problem, notice it says evaluate the following expressions with rational exponents using the exponent properties. So just like the first section on this page, we were evaluating rational expressions, but this time you also have to use your properties. So it's a little bit of both sections kind of put together. Notice that this 8 base is the same. Just like when we had x's the same as a base, the product property says that the 8 will stay the same. What happens with the 1/2 and the 1/6? Well, we need to add those. And unfortunately, I don't know what that is in my head. I have to come down here and get a common denominator. My LCD between 2 and 6 should be 6. So that means on the first fraction, I'm going to multiply by 3 to get 3/6. On the second fraction, I'm going to multiply by 1, and that just gets me 1/6. And 3/6 plus 1/6 is 4/6. Now, this one I can reduce. 4/6 reduces to 2/3, so we have 8 to the 2/3. And on the last couple of problems when we were evaluating expressions with variables, we were done at this point. But I can't be done at this point because 8 to the 2/3, that can be reduced. Because when I have an a base of a number, I can rewrite it as a radical, and I have the cube root of 8, and then I can either square the 8, or I could take the cube root first and then square the whole thing. I prefer to take the cube root first just to make things smaller before I make them bigger, and that helps me deal with smaller numbers instead of large ones. The cube root of 8 is 2, and 2 squared is 4. So the reason I could keep going on this problem is because 8 was a number base and not a variable base, which meant I could keep going. The next problem is very similar to it, except it's a division. So instead of adding my two exponents, I'm going to be subtracting by using the quotient property. What happens to the base 8? Yep, that's right, it stays 8. And I'm just going to take the top one minus the bottom one, and that will leave my leftovers in the top. 1/2 truly is bigger than 1/6. So I have 1/2 minus 1/6. My LCD looks like it's 6. So I'm going to have to multiply the first fraction 2 by 3 in order to get it to be 6. The second fraction I'm going to multiply by 1, and then it's 1. So 3/6 minus 1/6 this time gets me 2/6, and 2/6 reduces to a third. So this answer is 8 to the 1/3. Now, if 8 was a variable, I wouldn't have to do anything else. But because 8 is a number and not a variable base, that means I can change it into a radical. So I have the cube root of 8 to the 1. Well, to the 1 doesn't really help much, does it? We don't need to write that. And the cube root of 8 is just 2. So that final answer is 2. And that concludes this lesson on radicals.